Quantum electrodynamics (sad face, QED) is a quantum field hypothesis that portrays the communication of light and matter. It is perhaps of the best and very much tried hypothesis in physical science, and has been utilized to make exact forecasts about many peculiarities, including the energy levels of molecules, the dispersing of light from issue, and the creation of electron-positron matches. The sheep shift. The sheep shift is a little change in the energy levels of molecules because of the communication of the electrons with the vacuum. QED anticipated the sheep shift to be around 1040 electron volts, and this was subsequently affirmed by Explore. The irregular attractive snapshot of the electron. The peculiar attractive snapshot of the electron is a little deviation of the electron's attractive second from the worth that would be normal in the event that it were an old-style point molecule. QED anticipated the strange attractive snapshot of the electron to be around 1.166, and this was subsequently affirmed by examination to an extremely serious level of accuracy. The development of electron-positron matches. Electron-positron matches can be delivered when a photon has sufficient energy to make both an electron and a positron. QED anticipated the likelihood of electron-positron pair creation, and this was subsequently affirmed by TRI. Quantum chromodynamics (sad face, QC) is a quantum field hypothesis that portrays areas of strength for the, which is the power that ties quarks together to frame protons and neutrons. It is one of the four key powers of nature, alongside electromagnetism, gravity, and the frail power. Quarks have a property called variety charge. Variety charge is similar to electric charge, however, rather than two sorts of charge, positive and negative, there are three kinds of variety charge: red, green, and blue. The mass range of hadrons. Hadrons are particles that are comprised of quarks. QCD anticipated the majority of various sorts of hadrons, and these expectations were subsequently affirmed by Explore. The solid coupling consistent. The solid coupling steady is a proportion of the strength of the solid power. QCD anticipated the worth of the solid coupling consistent, and this forecast was subsequently affirmed by Analyze. The presence of repression. Restriction is the peculiarity that quarks can't exist in disengagement. QCD anticipated that quarks should be limited to hadrons, and this forecast was subsequently affirmed by Explore. Quantum gravity (sad face, QG) is a hypothetical system that joins quantum mechanics with general relativity. It is an endeavor to depict how gravity functions at the quantum level. General relativity is an old-style hypothesis of gravity that portrays gravity as a bend of spacetime. Quantum mechanics is a quantum hypothesis that portrays the way of behaving of issue at the nuclear and subatomic level. Grasping the early universe. Quantum gravity could assist us with figuring out the material science of the early universe, including the enormous detonation. Growing new advances. Quantum gravity could prompt the improvement of new innovations, for example, quantum PCs and twist drives. Bringing together the laws of physical science. Quantum gravity could assist us with bringing together the four major powers of nature into a solitary hypothesis. Quantum trap (sad face, QT) is a peculiarity wherein the quantum conditions of at least two items are connected together so that they can't be portrayed freely. On the off chance that two items are trapped, estimating one item will quickly uncover data about the other article, regardless of whether the articles are isolated by a huge distance. There are various ways of making snared states. One normal strategy is to utilize a cycle called unconstrained parametric downchange, SPDC. In SPDC, a photon is parted into two caught photons. Wave-molecule duality (sad face, WMD) is a central idea in quantum mechanics. It expresses that all articles have both wave-like and molecule-like properties. One of the most popular instances of wave-molecule duality is the twofold cut tri. In the twofold cut tri, a light emission is terminated at a screen with two cuts in it. Wave-molecule duality is perhaps of the main idea in quantum mechanics. It has assisted us with figuring out various peculiarities, including the way of behaving of light, the design of molecules, and the idea of the real world. Wave-molecule duality is a genuinely noteworthy peculiarity, and it keeps on being a wellspring of miracle and interest for researchers and the public the same. Quantum registering. Quantum PCs could utilize wave-molecule duality to perform computations that are outside the realm of possibilities for traditional PCs. Quantum correspondence. Quantum correspondence could utilize wave-molecule duality to send messages that are secure from snooping. Quantum detecting. Quantum detecting could utilize wave-molecule duality to foster new sensors that are more delicate and exact than existing sensors. Superposition sad phase, SP, is a quantum mechanics rule that expresses that a quantum item can be in numerous states simultaneously. This intends that, until it is estimated, the item is in a condition of superposition of every conceivable state. One method for pondering superposition is to envision a coin that is turning. Before you take a gander at the coin, it is in a superposition of being heads and tails. Just when you take a gander at the coin does it break down into one state or the other. One more illustration of superposition is the twofold cut analyze. In the twofold cut explore, a light emission is terminated at a screen with two cuts in it. Assuming light were made of particles, we would hope to see two particular lines on the screen, one for each cut. Nonetheless, what we really see is an impedance design, which is what we would hope to check whether light were a wave. Superposition is a vital idea in quantum mechanics. It assists us with figuring out the way of behaving of light, the construction of iotas, and the idea of the real world. Quantum figuring. Quantum PCs could utilize superposition to perform computations that are outside the realm of possibilities for traditional PCs. Quantum correspondence. Quantum correspondence could utilize superposition to send messages that are secure from snooping. Quantum instant transportation. Quantum instant transportation could utilize superposition to magically transport quantum data starting with one area then onto the next. Quantum burrowing sad phase, QB, is a peculiarity where a quantum particle can go through a hindrance that it wouldn't have the option to traditionally survive. This is on the grounds that quantum objects have a wave-like nature, and waves can burrow through hindrances. One method for pondering quantum burrowing is to envision a ball attempting to turn over a slope. Traditionally, the ball would have to have sufficient energy to move past the highest point of the slope. In any case, quantum precisely, the ball can burrow through the slope regardless of whether it have sufficient energy. This is on the grounds that the ball is in a superposition of being on the two sides of the slope simultaneously. Quantum burrowing is a vital idea in quantum mechanics. It assists us with grasping the way of behaving of particles and cores, and it has numerous mechanical applications. Burrowing diodes. Burrowing diodes are semiconductor gadgets that utilization quantum burrowing to direct power. Burrowing diodes are extremely quick and proficient, and they are utilized in different electronic gadgets, like microwave speakers and oscillators. Checking burrowing magnifying instruments. Filtering burrowing magnifying lens use quantum burrowing to picture surfaces at the nuclear level. Examining burrowing magnifying lens are utilized in different fields, like materials science and surface science. Quantum burrowing is as yet a somewhat new field of exploration, however it can possibly reform various areas of science and innovation. Quantum decoherence sad phase, QD, is the cycle by which a quantum framework loses its intelligibility and starts to act like an old-style framework. This is on the grounds that quantum frameworks are exceptionally delicate to their current circumstance, and, surprisingly, little cooperations with the climate can make them decohere. One method for pondering quantum decoherence is to envision a turning coin. Before you take a gander at the coin, it is in a superposition of being heads and tails. Be that as it may, when you take a gander at the coin, it implodes into one state or the other. This is on the grounds that the association between the coin and the light from your eyes has made the coin decohere. Quantum decoherence is a vital idea in quantum mechanics. It assists us with grasping the change between the quantum and old-style universes. Quantum decoherence is really difficult for quantum figuring. However, analysts are growing better approaches to forestall quantum decoherence to fabricate bigger and all the more impressive quantum PCs. Quantum correspondence. Quantum correspondence utilizes quantum snare to send messages that are secure from listening in. Quantum decoherence is likewise difficult for quantum correspondence. However, analysts are growing better approaches to forestall quantum decoherence to foster down-to-earth quantum correspondence frameworks. Quantum decoherence is a captivating and significant subject of examination with the possibility to upset a wide range of areas of science and innovation.